properties. Let's do some of the properties of these amines. Okay, so as I told you, the properties means physical properties are there, chemical properties are there, right? We know that properties of the compounds can be mainly classified into physical and chemical. So I told you physical properties means it is based on the what is the nature, what is the is it solid, liquid or gas, then what is the boiling point, melting point, what is the solubility, what is the color of the compound, then they are called physical properties. Then they will talk about the reason for that properties. So what is the reason for the solubility, what is the reason for this highest boiling point, what is the reason for the lowest melting point, like that they will tell. That is physical. Chemical properties means completely the chemical reaction, how they react with suppose an acid, how they react with the base, how they react with the water, like that. They are called chemical properties. Okay, the lower aliphatic amines are gaseous in nature with foul odor. First point, amines normally have a not that much good smell. Okay, they have a bad odor, like that. Okay, foul odor. First one. Primary amines having 3 or more carbon atoms are liquids, while amines containing higher carbon atoms are solids. The same thing we discussed in the previous chapter. When the number of carbon atom is increasing, the interaction between them will increases, right? So the interaction between the particles, individual particles or the individual molecules will increases. So they will become closer. Closer means when the number of carbon atom increases, the intermolecular interaction will increases. When the number of carbon atom increases, intermolecular interactions will increases. So what will happen? The melting and so the nature will move from gas to liquids to solids. Normally they are so liquids, but with the number of carbon increases, it become solids. But all the compounds are organic compounds are volatile, we know, right? Yes. That is same thing is here also. Got it. Then aryl amines and aniline do not have any color naturally, but get color due to the atmospheric oxidation during storage. Normally, these aryl amines and aniline, they do not have any color. But you know, anilines, after some time, when you are keeping in laboratory, after some time you can see there is a brown color for aniline. Means aryl amines. They have a brown color. Actually, this color is not the correct color. That is the perfect color of the compound. This color is due to the atmospheric oxidation during storage. Normally, they won't have any color. Due to the storage, due to the atmospheric oxidation, they are getting some color. Okay, yes. Then, lower aliphatic amines can form hydrogen bonds with the water molecule, hence being soluble in water. So, what is hydrogen bond? Bond between hydrogen and high electronegative atom like nitrogen, oxygen, fluorine. That is called a hydrogen bonding. Okay, hydrogen bonding means the force of attraction, the bonding between the intermolecular. It is a type of intermolecular interaction. It is between hydrogen atom and high electronegative atom like nitrogen, oxygen or fluorine. So in case of amines, there is nitrogen atom, we know. So what will happen? Lower aliphatic amines can form hydrogen bonds with the water molecules, hence being soluble in water. Amines can form hydrogen bonds with the water molecule. Amines will form hydrogen bonds with the water molecule. That is important. That's why they are commonly soluble in water. See, suppose I am taking an amine. See, this is the alkyl group. Suppose suppose it's a secondary amine. Suppose this one is dissolving in water. Water means H2O, right? Yes. So this nitrogen can interact with this hydrogen. This interaction, this bonding is called hydrogen bonding. Got it? So the lower aliphatic amines, only aliphatic I told you, not aromatic. So the lower aliphatic amines can form hydrogen bonds with water molecule, hence being soluble in water. Okay, this diagram is not that one. This is the intermolecular hydrogen bonding between these amines only, not between amine and water. Got it? Got it? This diagram is not the interaction between water and the amines. This is between the amine molecules. Got it? Don't be confused. So between the amine molecules also, I told you, when the number of carbon atom is increasing, their nature is moving from liquid to solid. Why? These intermolecular interactions will increases. Got it? Due to this increase in the intermolecular interaction, this nature is moved from liquid to solid. So between the ammonia molecule, what type of interaction is existing? That interaction is again hydrogen bonding. So between the amine molecules, hydrogen bonding is there. Between water molecule and amine molecule also, hydrogen bonding is there. Got it? Between amine molecules, hydrogen bonding is there because the hydrogen bonding is between hydrogen and high electronegative atom like nitrogen, oxygen and fluorine. So between amine molecules, hydrogen bonding is there. Between ammonia and water molecule, hydrogen bonding is there. Got it? Any doubt? Sure? Yes. Then, next one. Okay. So, next one is, see the solubility, right? So between the water and the amino molecules, means amine molecules, hydrogen bonding is there. Between amine molecules also hydrogen bonding is there. That is called a intermolecular hydrogen bonding. So this diagram indicates the hydrogen bonding between molecules itself, not between water and the amines. Got it? Yes, this is the property. Next one. Alcohols are more polar in nature than amines due to stronger intermolecular hydrogen bonds. Hence, alcohol is soluble in organic solvent like either benzene and alcohol. See, alcohols are more polar in nature than amines. Why? What is polar nature? Polar nature means this is due to the difference in the electronegativity, right? We know that because when suppose in a board, suppose I am writing a simple example. Suppose you are taking HCl molecule, HCl. Chlorine is more electronegative than hydrogen. So these covalently bonded electrons will move more towards chlorine. So del negative will be here, del positive will be here, right? Yes. So now this molecule we can call it as this is a polar molecule. Alcohols are more polar in nature than amines due to the stronger intermolecular hydrogen bond. Got it? So, if you are comparing the polarity of amines with alcohols, alcohols are more polar in nature. Why? Stronger intermolecular hydrogen bonds. Alcohol is soluble in organic solvents like either benzene and alcohol. It's the same thing. Okay? Yes. Now, the boiling points of isomeric amines is in the order primary, secondary, tertiary. Means among primary, secondary, tertiary, which one have more boiling point? That is for primary. If you are comparing the boiling points of primary, secondary, tertiary, the more will be for primary amines. Okay, any doubt? Yes. Then, so what is boiling point? We know, right? This is the temperature at which the liquid is converting into vapor form. So if you are converting an aniline and some other secondary, tertiary, the primary have the highest boiling point. Isomeric amines. Isomeric means same form, similar formula is there. Okay. Then intermolecular association takes place between primary and secondary amines due to hydrogen bonding between the nitrogen of one and hydrogen of the another molecule. Intermolecular association between primary and secondary amine is due to hydrogen bonding. See, hydrogen bonding, I told you, the interaction between hydrogen and electronegative atom like nitrogen, oxygen or fluorine. So, intermolecular association between primary, secondary and means these amines due to hydrogen bonding. How? Because any amine you can see nitrogen and hydrogen is there. This is a primary amine, right? I am taking next primary amine. Hydrogen, nitrogen, hydrogen, R group. So this interaction, this is the hydrogen bonding. In the previous diagram, you can see that, right? Yes. Got it? Yes. Then second term is due to hydrogen bonding between nitrogen and of one and the hydrogen of the other molecule. Got it? So this is the boiling point of these amines. Okay, any doubt in this topic? Sure. So we discussed about the lower aliphatic amines are gaseous in nature with a fluoride. I told you physical properties means we are dealing with the nature, physical nature, boiling point, melting point, solubility, like that. Okay, so we will discuss about the intermolecular interaction. Okay, so the lower aliphatic amines are gaseous in nature with a foul odor, I told you. Then primary amines having 3 or more carbon atoms are liquids, I told you, while amines containing higher carbon atoms are solid, as I told you in the previous topic also, right? Because when the number of carbon atom is increasing, the interaction will increase, so the liquid nature to solid nature means the nature is increasing. The solid nature is that one is means it is more than that of the liquid. Got it? Yes. So when the interaction is very high, they will exist in, they have a tendency to exist in close pack, means it is liquid or solid manner. So that's why they are combining in together to produce the liquid state or solid state. Aryl amines and aniline do not have any color naturally. I told you. Normally, if you are seeing an aniline, means it is a compound. It is a brown colored compound, I told you. But normally the aniline is not colored. Why they are having that color? Because they are oxidizing during the storage. Normally they have no any color. They are oxidized during the storage. That's why they are getting a brown color. If you are taking a tertiary amine, also same. If you are taking a secondary or tertiary, primary, all the aryl amines are similar. They are not having color. They will be colored due to this one. The oxidation, natural oxidation. In presence of air, they are undergoing oxidation. Okay. Lower aliphatic amines can form hydrogen bond with water. I told you this is the representation between the amine molecule, not between amine and water molecule. Okay. So this is the main properties. Then I told about the boiling point. So if you are taking amines, which one have high boiling point? Primary, then secondary, then tertiary. Why it is like that? Why the tertiary have less boiling point? I told you the boiling means we have to separate the molecules. When the interaction between the molecule is so strong, not easy to separate, right? When the interaction between the molecules are strong, not easy to separate. So in case of primary, this is primary. Hydrogen is there, hydrogen is there, hydrogen is there. I'm taking another primary. One hydrogen, one CH3. So here, 2 hydrogen atom and 1 nitrogen atom. So they can produce hydrogen bond between them, right? Yes. Now I am taking secondary. Secondary means 2 hydrogens will be replaced by alkyl group. then only one hydrogen is available, and in each one nitrogen is available. One nitrogen means it is not changing, always one nitrogen is there, but the number of hydrogen is decreasing in secondary. Then what is happening in tertiary? Tertiary means all the three groups are alkyl groups. When all the three groups are alkyl groups, what will happen? What will happen? See, there is no hydrogen atoms available for making hydrogen bond. Got it? If hydrogen bonding is there, that hydrogen bonding is the intermolecular interaction between these amines. When this, I told you, comparing to other intermolecular interaction, hydrogen bonding is stronger, right? So in amines, hydrogen bonding is there, means there is a stronger interaction between these individual molecules. If there is no possibility for any hydrogen bonding, it means the boiling point will be comparatively less. Okay, that's why tertiary have low boiling point, because in tertiary there is no hydrogen. All the three hydrogen atoms are replaced by alkyl group. So there is no means proper amount of hydrogen is not there. So they are not able to form hydrogen bond between them. So that's why they have comparatively low, means the interaction between the tertiary amines will be less. The interaction between tertiary amines will be less. So not easy to break the bond. It is easy to break the bond. So the boiling point will be less. So in case of primary, the hydrogen bonding is there, because in case of primary, only one hydrogen is replaced by alkyl group. So the interaction is there. Interaction is there means there is a intermolecular interaction. There is a hydrogen bonding. So not easy to break the bond. Boiling point will be high. Okay. So that is the reason for the means difference in the boiling point of primary, secondary, tertiary amines. Got it? Yes. So this is the property.